Hello and welcome back to enrichment, back to integration, indefinite limit for us to, indefinite integral for us today. Pause the video if you want to have a go at it. I'll call it enrichment. It's not actually that bad, this particular one, and see if you can have a go. Otherwise, wait for the solution. Only I think straight maths is required for this particular one. Okay, so if you didn't pause, or if you paused and you can't quite see how to do this particular one, this is not actually too difficult for one reason. With a lot of difficult integrals, the main problem is you don't know where to start. For this particular one, I think it's kind of obvious the starting point. Of course, this is a mess. We like to get rid of that, so get rid of this. So quite clearly, a substitution is in order. So we're going to use a substitution, of course. Do we use a substitution 5 arc sine or just arc sine? Me personally, of course, I will go for just the arc sine. So we're going to say, because the arc sine is an angle, let theta equal to the arc sine of x. We can differentiate it as it is, but it's probably better to take sines on both sides. Sine theta is equal to x. And then I can say my dx, looking at this, is equal to the differential of sine, which is a cos of theta d theta. We also have limits to change. So the limits now, when x is equal to 0, it will map, the arc sine of 0 is of course 0, and when x is equal to a half, the arc sine of a half maps to theta is equal to pi over 6. So far so good. Let's see how this transforms now. So this particular integral now will become integral from 0 to pi over 6, the cos of 5 theta, and my dx is just the cos of theta d theta. And now how we do an integral which looks like that. That's why I said I'm not quite sure if this is quite enrichment. The first step I'd like to think was obvious. Once you go through the substitution, you get this. And the next question is, do you know how to do an integral which looks something like that? It requires specialist techniques. In fact, I'm not quite sure these days if they give you some trigonometric identities in the formula booklets to change this. But if they don't, or if we don't have access to that, this is how we deal with an integrand which looks like this. Well, the product of cos 5 theta cos theta comes from the expansion, the compound angle expansion of cos 5 theta plus theta. It will produce something which looks like that. So I can say this is definitely cos 5 theta cos theta minus the sine of 5 theta times the sine of theta. This is my motivation. But of course, I have this unwanted term, which I can easily get rid of by actually writing the compound angle for cos, but with a minus this time. This will produce exactly the same thing, of course, but with a plus in the middle. So let's see how this will simplify things. Plus sine of 5 theta sine theta. What I want to do next, because I don't want this particular quantity, I'm going to add both sides of these two expressions. And of course, I don't need to write any more as 5 theta plus theta. That's simply the cos of 6 theta. So I can actually say the cos of 6 theta, that's this bit here, plus the cos of 4 theta is definitely equal. This will now cancel on addition. 2 lots of my cos 5 theta cos theta. So now I can transform my integrand here and say, well, that's definitely because I don't have that 2 in there. I'm going to have this quantity, but only half. So I can replace it with a half cos of 6 theta plus 1/2 cos of 4 theta d theta. And let's not forget the limits, which are, of course, 0 to pi over 6. And let's clear the board. We don't really need this anymore. Very easy integration from here. So we got, of course, a sine of 6 theta with, of course, 1/12 in front of it. I don't need to adjust signs, plus or minus when I say signs, for this particular one. And this, of course, comes from the differentiation of sine of 4 theta. We need the quarter, obviously, take care of. So that's going to be an 1/8 between the limits of 0 and pi over 6. Okay, so substituting in, when I put pi over 6, 6 lots of pi over 6 is pi, the sine of pi is 0. Let's record what we're getting anyway. 0 from pi over 6 in there. Pi over 6 in there gives us a sine of 2 pi over 3, that's root 3 over 2. So it's going to be plus root 3 over 16 from this term here on the pi over 6. And the sine of zeros, which we have in there, is of course just zeros. So in fact, the answer to this particular integral is the square root of 3 over 16. Is actually not as bad. I did call it enrichment. I'm not quite sure how many stars I will rate this particular one. I've only just written this morning, by the way. I forgot to mention it. I'll probably call it a 4.5 if I don't give any assistance in this work, and just say basically use appropriate integration techniques to do this. Is just probably a 4.5 star. I hope you enjoyed it. Who's laughing now?